All right, we are shifting this ellipse now. And so on the next page of your notes, you are given this table right here. And this is also given to you in the back of your spiral. For right now, it's on page 227, but that could change. But you have a conic section formula sheet. And I should have explained this with circle. You are going to be given this specifically for my on-campus students. You're going to be given this entire formula sheet. It's got circles and ellipses on the front, and then hyperbola and parabolas on the back. You're going to be given these. You need to know how to use them. So as you're working through your homework, try to flip to page 227 and only use this formula sheet to help you. Now, if you need to go back into your notes as more of a guide, please do so, but try to use what you're going to be given on the test. So try to use this formula sheet as you're working through your homework. So I just took this from your formula sheet, copy and pasted it here into your notes. So we have our two different versions. Here's when it's parallel to the X, and we can tell that it is parallel to the X-axis when my B is under my X, or sorry, oops, when my A, right? When my A is under my X. And we know which one is A or B because I have a little note down here that A is always the largest number. Then up here, we know when our equation or when our ellipse is parallel to the Y, because our A, our larger number, is under the Y. So that's how we can tell the difference. Now you have an example of it being elongated along the X and elongated along the Y. And here are all 7 of your points that you need. For both of these, the center is HK. So again, notice inside opposite, because this is minus H and minus K, but then it comes out to HK. So inside opposite. And then these change slightly, so you need to make sure you use the right column, depending on if it's parallel to the X or to the Y. So let's try this one here. Write the equation for the ellipse, and we have a picture of one. So we need to identify what is my major axis, because that will tell me which version of my formula that I'm using. So my major axis is parallel to the blank axis. And it's parallel to what? Well, my major axis is elongated along that Y. It is parallel to the Y-axis. So because it's parallel to the Y, we need to use this version here of my formula. So we have X minus H squared over B squared plus Y minus K squared over A squared equals 1. So I need 3 things. I need the center, and I can see the center right here. My center is at 4, 0, so there is my H and there is my K. So I know what I'm plugging in for H and K. Now I need my A and my B. My A is the larger number, so I want to go from here to this major vertex, or from here up here to this major vertex. So I don't go over on my own writing in that point. I'm going to go down. So I'm going to go 1, 2, 3, 4, 5, 6. So here A equals 6. And now I want to go over here to my minor vertex or over here to this minor vertex for my B. So we go 1, 2, 3, 4. My B is 4. So now I have my A and B, and I have my H and my K, so let's plug it all in. We have X minus H, which is 4, over B squared, which is going to be 16, plus Y minus K. If my K is 0, Y minus 0 is just Y squared, and then A squared will be 36. and this equals 1. So going from graph to equation is very, very straightforward. Find the center and find the distance from center to minor and major vertices. Okay, let's continue on to the next page. Number 6, we need to find the equation of an ellipse that is, and I'm going to plot these as I read them, that is centered at -1, 2, one focus at -3, 2, and a vertex, talking about major, at -5, 2. So we need to find this equation and then we will graph it. Okay, so let's start by identifying that major axis. And here that major axis is parallel to the length axis. And because they're all in a line horizontally, parallel to that x-axis, it is parallel to x. So that tells me then which version of my formula I'm using. Because it's parallel to my x, I'm using this one right here. So we have x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, so let's figure out which variables I have here. My a is the distance from my center to my major vertices, so that's 4. I don't know b because I don't have anything about my minor vertices, but c, that distance from center to focus, is 2. So let's use b squared plus c squared equals a squared to find my b, or really just my b squared. So b squared equals 4, or sorry, b squared plus 4 equals 16. So plug in 2, plug in 4, subtract your 4, we get b squared equals 12. So now I'm going to plug in b squared equals 12 into right here. Okay. I also do have my center. That tells me my center is at -1, 2. So there is my h and my k. So when we plug in, I've got x minus a -1, so x plus 1 squared over a squared of 16 plus y minus k, my k is 2, over b squared, which we just found down here to be 12. And that equals 1. So there is my equation. And now we need to graph. So before we graph, let's figure out what b actually equals. So I'm going to go in a different color here. Take the square root of both of these, which I think we've already done this before. This is 4 times 3, which is 2 times 2. So we're going to get 2 square root 3. But for graphing purposes, that is 3.5. So you can see my major and minor are almost identical. So this is going to be more circular-like. These are pretty close together. Okay, so now I got everything I need. So let's plot this. So I already have one focus and one major. Let's get the other one. So from center to focus is 2. I'm going to go 2 in the opposite direction. And then from center to major, I'm going to go 4. Notice I'm not going that many from the y-axis. I'm going that many from the center, right? So it's 1, 2 units over, 1, 2. So this is 4. I'm going to go 1, 2, 3, 4 right here. And then use your B to find your minors. From C, we're going to go down 1, 2, 3.5. And we'll go up 1, 2, 3 and a little extra. And now let's connect our vertices together. And there is my janky looking ellipse.